Hi and welcome to the Neil Ashton podcast. In each episode, we explain some of the fascinating ways that science and engineering are changing the world around us. We talk to leading engineers from elite level sports like cycling and Formula One, to some of the world's top academics to understand how fluid dynamics, machine learning, supercomputing are bringing in a new era of discovery. We also hear some of their life stories, their career advice, and lessons they've learned on the way that I hope will be helpful to you too. So sit back and enjoy this episode. Welcome back to the Neil Ashton podcast. So really excited actually. This is one of the interviews I was planning to do when I created this podcast, in the sense these are the sort of individuals that I really wanted to speak to and for you to hear from. Because I think they're that blend of engineers, but they've been in such privileged positions, such unique positions, that they sort of give you an insight into a world that very few of us get to ever see. So Pat, I worked with him on the Formula One sort of next-gen car program. That was the 2022 change in rules. And so for a couple of years, I worked quite closely with him, and I had a huge amount of respect for his technical knowledge, but also his leadership and just the kindness that he has towards individuals he works with, and very much a sort of future thinker. I think there's a bit of a trend in Formula One that sometimes people can be a little bit conservative and sort of not always adapt the sort of latest methods, which is, I know, a bit ironic to say that, but it is true. It's quite a conservative business. Whereas Pat's always thinking about the future, which I really like. Now, we actually did this interview a few days before he announced that he was actually leaving Formula One after 7 years as their CTO, and actually has moved over now as executive engineering consultant to Andretti. This happened a few days afterwards, so we don't discuss it in the talk, but it's kind of interesting to know that after doing this interview. We go through lots of topics, as with any of the guests I've had. I feel we could have spoke for many more hours, but we start from the early days, what motivated him to get into engineering, into Formula One. I love hearing the stories and the way that Formula One has evolved, particularly the way the paddock was, and not this amazing show that it is today. But something, more like a Formula 2 or Formula 3, of course, when he started. His times moving through Tolman to Benetton to Renault, of course, with Michael Schumacher being the race engineer, and then sort of discussing rising through the ranks and almost a reluctance in a way to go into these very managerial positions because he was such an engineer. Of course, he then went on to have time at Virgin, at Williams for a few years, and then, of course, with Formula One. And we talk about some of that project of changing the rules, and we talk a little bit about his vision for the future, where he would like the sport to go. So I think he's someone who I think people can learn a lot from. He's had an amazing career, and it's not over yet, not at all. He is super ambitious and still has so much energy. So yeah, I really hope you enjoy this episode with Pat Symonds. We've known each other a little bit, and I can't think of many people who have done as much as you have. But was this all planned? Did you have some grand vision when you were 15, 16 that you would be winning world championships and being technical director? Did you always want to be an engineer?
Yeah, I think it was 12 actually, not 15 or 16. And it's interesting because many years ago, someone asked me, was there a point where you really decided what you wanted to do? And I said, no, not really. I grew up, my father was an engineering officer in the Air Force, and he loved cars, he loved racing, he loved aircraft. And so I sort of grew up in that engineering environment, and I was every weekend sort of helping him take his car to bits, put it back together, etc., etc. But therefore I thought, I want to get involved with this, and I want to design cars, and that was certainly when I was by 11, 12, knowing this. And my father used to take me to races. We lived up in Norfolk, so we'd go to Snetterton quite often. And I think, the real turning point to me was Good Friday, 1967, believe it or not. There was a race at Snetterton that day, and been to many races before, but this particular one, it was an international. All the top drivers were there. It's the first race of a new Formula 2 formula, and there were GT40s in the support races and all these wonderful cars. And I thought, yeah, this is something I want to get involved in. And I was quite focused. Now, of course, I didn't think I'd get into racing the way I did, but that's perhaps another story. But I certainly decided that A, I wanted to design cars, and B, that I wanted to work for Ford, because Ford were, they were everything in motorsport in those days. And, they have such a great motorsport history. And so worked my way through school and applied for an undergraduate apprenticeship with Ford, which I was lucky enough to get. And that really set me going.
Okay. But did you have a particular type of engineering was it more on the electronic side, mechanical side? Was there a sort of...
No, mechanical, definitely. And in fact, when I did my Ford undergraduate apprenticeship, I actually did an HND first rather than a degree, because my A-level results hadn't been quite what I needed them to be. And so I did my HND in mechanical engineering, and then I did a master's in automotive engineering. So I had that sort of background of mechanical, and then went on to do automotive. And my sort of specialization was vehicle dynamics then. Of course, this was in the days long before there were any motorsport engineering type courses, of which there are many now. But that was my aim, was to go and work for Ford and design road cars. But in actual fact, by the time I graduated, it was in the mid-70s. In fact, when I finished my HND, I looked at what was going on at Ford, and it wasn't a great time in the British motor industry. It wasn't a great time in Britain, to be honest. But Ford were really in a bit of a transition, and Ford in the USA had sort of decided that Germany would do the cars and Britain would do trucks and vans and things like that. And that didn't appeal to me much. And in addition, they'd very much got into this sort of component engineering, very specialized things. So, you could be the guy who knew more about tooth cam belts than anyone in the world, but you never really got to design the whole vehicle. So it wasn't that appealing. And that's actually why I went and did my master's, to sort of hope that the industry would pick up a little bit. But at the end of that, it still wasn't looking good. And I went to Cranfield, and when I was at Cranfield, there was actually an advertisement appeared on the notice board in the university, and looking for someone to help a little company called Royale, who wanted to do a Formula 2 car. And I thought, I'll go and apply and see what happened. And so I went and did that, and I met Rory Byrne, who became quite a big part of my life later on. And I got the job. I thought, that's great, And then I found out what motor racing's really like, because, of course, as soon as I got the job and I decided I wasn't working for Ford anymore, the sponsorship money that was going to build this Formula 2 car disappeared.
Classic motorsport.
Absolutely. And so the job disappeared. But by this time, I got the bug. So I just wrote to everyone I could think of and said, I was graduating and I wanted a job. And I actually got a job with Hawk, who were a competitor of Royale, making Formula Fords, Formula Ford 2000s, down in Southend. And I went to work there. And it was a bit of an eye-opener, actually, because I arrived and there was a little porter cabin. They said, okay, this is where you're working. And I walked in there and there was no one else there. So I realized then I was the designer. There was no one else. And straight out of university. And it's like, oh, okay, where do I start? And I started by sort of saying, well, look, I've learned a lot of engineering. I've learned a lot about vehicle dynamics. Let's see what we need to do with these cars. And it started off with a Formula Ford car, and they ran on Dunlop tyres. So I got hold of Dunlop and I said, I need some tyre data. And they said, oh, well, we've never been asked for that before, but yeah, we can get some. So I got some very basic tyre data, and I did a few calculations because didn't have a computer or anything like that. In fact, actually, when I was in Southend working for Hawk, I actually enrolled at the local technical college on a welding course. And I did that because, I wanted to learn to weld, but also it meant I could use their computer. And so I wrote a suspension geometry program. And
how common was that attitude of, one, you'd done a master's, you'd gone, was motorsport at that time predominantly people who hadn't almost gone through that path, and it was more sort of old school?
Yeah, absolutely. I was very lucky in a way because I was one of the first sort of academics, who got involved. Now that sounds a bit grand because, of course, there are a lot of people around, people like Patrick Haig, Colin Chapman. They had degrees, a lot of very, very clever people as well. But there was still an awful lot of people who were the sort of traditional engineers, self-taught, particularly trackside. But yeah, I'd actually done automotive engineering. I'd specialised in vehicle dynamics, but I'd done all the other modules as well. And so, I started to apply that sort of thing. And the cars were actually very successful. In fact, the first race I attended in a professional capacity was the Formula Ford Festival in 1976. And we finished first, second and third in that. And I thought, oh, okay, this is easy. How wrong I was. I mean, it's anything but easy. But I did the Formula Ford car there, the Formula Ford 2000. I did a Formula 3 car, which was run by Jan Lammers in the European Championship. It wasn't a terribly successful car, to be honest. It was a bit overweight, and it took a lot to get the weight off the car. But it was competitive, so it was a great way to start. And then things progressed, I guess, because Hawk was a fantastic place to work because we had a big machine shop, big fabrication shop. We were doing everything, but like so many times in motorsport, finances were strained, and after the paycheck had bounced a couple of times, you sort of think, oh, I wonder if there's something else around. Now, at this time, it's funny because it goes back to that advertisement at Cranfield, because Rory Byrne was chief designer at Royale, and he was going to Tolman. He was leaving Royale. Tolman were going to build their own cars in Formula 2 Championship. Rory knew all the Tolman people, so he went off to do that, and he recommended to Alan Cornock, who owned Royale, that perhaps I was the guy to take his place. So that's what I did. I moved to Royale and did a few years there, which were very, very successful, actually. Formula Ford, Formula 2000. We didn't do anything beyond that, but we set a record for the number of races won in a year. We built a Formula Ford 2000 car that I think the first time it got beaten was sort of end of August of that season. It was a really good time. And ultimately, it led to when Tolman decided to go from Formula 2 to Formula 1, they asked me to join them on the Formula 1 program. So it's interesting because in those early days, in 76 when I graduated, and I said, right, I'm going to do a 3-year program. I'm going to 3 years in motorsport, then I'll go back to a proper job. And I'm on year 47. 3-year
project.
Yeah, that's kind of crazy. Were you watching Formula One at that time? Were you sort of a big fan of the sport, or were you? Do you know what I mean? Were you always obsessed with Formula One even while you weren't in it?
Yeah. No, always a big fan. You know, the bedroom wall had all the pictures of the Lotus 49, things like that. You know, going back to the sort of 60s. So yeah, always a big fan of racing. Even when I was at school, you know, we formed a motor racing club, and we used to go off to races. In fact, quite an interesting story was that when I was at school, at the end of one summer term, you know, that last week when you're sort of talking about things you're going to do, and one of our teachers said, "Okay, what are you guys going to do when you leave school?" And one of my friends said, "I'm going to be a racing driver." So I thought, I'll say I'm going to design racing cars. So I said, I'm going to design racing cars. And we got laughed at. But actually the joke turned round, because that guy was a chap called John Village. And in probably, 1979, 1980, I designed the car that he won the European Championship in. So we did actually achieve what we said we were going to do.
That's amazing. You know, I was just going to ask you before we maybe move on a little bit. You know, during those times when you were starting, I think now, if you were to join a company and you didn't know something, you could just Google it. You could look online. When you were put into that situation and you didn't know how to do it, that sounds like a very practical question, but what did you have to do at that time? Was it going to the local library? How did you get that information?
Yeah, I mean, it really was difficult, and it is amazing what you can Google, and you know how that can sometimes mislead you. But yeah, you did just that. You went to your local library, and you looked it up. You know, all your stress calculations came from Machinery's Handbook, and you know, there were well-thumbed copies of that. And you know, that was an expensive sort of book, but you had to have it because that was your basis for all the formulas and things. But of course, you had all your college notes and referred to those a lot.
Yeah. So then at Tolman, so what was the progression like there? So they were then trying to get into Formula One, right? That was those times. So what was that experience? How did you move?
Yeah, it again, you know, very, very different then. The teams now are huge, and they take on a lot of graduates, and there's a lot of progression through the teams and what have you. But when I joined Tolman, I was employee number 20. So there were 20 of us. We had an ambition to go Formula One racing. And we had a lot more ambition than we had ability, I would say. So Tolman had just come off the back of a very, very successful Formula 2 season. They built their own cars. Brought Pirelli into the sport, dominated the Formula 2 season in 1980, and so they decided in 81 to go Formula 1 racing. And I think the sort of people involved, Ted Tolman, who died just recently, Alex Hawkridge, who was what we'd now call the team principal, Rory Byrne, chief designer, very, very ambitious people and lateral thinkers. So when they went into Formula One, they said, okay, we're not going to just follow the route of building a car, putting a Cosworth DFE in the back, bolting on Goodyear tyres and running around with the rest of them. We're going to look at where things are going, and we're going to do it differently. So I guess the first decision was they needed a turbocharged engine. There were not many turbocharged engines around at the time, so they said, right, been successful with Hart in Formula 2, so we're going to turbocharge the four-cylinder engine. Something you'd hardly dream of doing these days with the sort of knowledge you have of how complex the combustion is on those engines. They decided that they would bring Pirelli into Formula One, but even then, you know, not do it the simple way. Everyone was running 13-inch wheels then, and we thought, well, you know, why are we on 13-inch wheels? It'd be much better if we could get onto a 16-inch wheel. We can get bigger brakes in there, all these sort of things. Even the monocoque, we decided not to do a carbon monocoque. We would do an aluminium monocoque, aluminium honeycomb. But whereas most people were sort of taking sheets of aluminium honeycomb, they were routing out a little bit, folding it and gluing it together. We actually made the monocoque in the same way that you would make a carbon monocoque. So we first developed the skins, then we used film glue, honeycomb, or put it in an autoclave and built it as if it was a carbon monocoque. So, trying to do everything right. And it was an absolute disaster. The car was just dreadful. It was so slow. In fact, in 1981, most races we didn't even qualify for, because in those days it wasn't like today where it's limited, where you only have 20 cars. We had an awful lot of cars and not many spaces on the grid. So we used to have qualifying to get into qualifying, if you see what I mean. In fact, sometimes there was even pre-qualifying to allow you into practice. So it was a pretty disastrous year. And I think from memory, we only qualified for a couple of races.
But what was it like, though? I'm just trying to bring it to the current time. So you said you were obsessed with Formula One, really into Formula One. You'd been in Formula 2 before. Do you remember those moments when you first went to your first F1 race as an actual part of the team? When you go into the paddock, was there, or had it become almost normal by then?
Well, yeah, that's interesting, because in 81, which was the first year Tolman were in Formula One, I didn't actually race engineer the Formula One cars that year. We had done a deal with Lola whereby they were going to produce the Formula 2 car. And because my job was sort of to set up the wind tunnel model and all this sort of stuff, because the first Formula One car had been built without a wind tunnel model even, set up all the R&D facilities and things like that. I didn't have time to go to the Formula One races, but I did actually have to do the support on the Formula 2 races. So that year I was running Stefan Johansson in the Formula 2 car, and really supporting F1 at a distance. So the first Formula One race I went to was actually the first race in 1982 in Brazil. And it's one of those, it's sort of serendipity really. We went there, we were still using the 81 car. We'd done some modifications to it, which we hope would make it a bit more competitive. We had just got the car in the wind tunnel at the end of the previous year. So we hoped, we were going to at least be qualifying. Went to Brazil, we didn't qualify. And so there was a bit of a meeting on the Sunday, and Ted Tolman and Alex Hawkridge said, right, we're going to change things. Rory and John Gentry, who's the other engineer / designer, it was decided they were going to stay back in the UK and they were going to design a totally new car, and I was going to run the team. So my first sort of really proper Formula One race, and by race 2 I was sort of in charge. So it was really being thrown in the deep end, which is actually, there's nothing wrong with that.
But what was it like at that? Was there a bit of a, because I can imagine the more established maybe teams or the people, and you come in there. I'm just trying to get a sense of what it was like in the paddock or the people around. Was it?
Well, firstly, it's very, very different. Yeah, the teams were much smaller. I said that when we started in Formula One, I was employee number 20. By the time we went racing, we were only in the 60s or something like that. In fact, I've actually got an organisation chart somewhere from that year, and I think there are about 63 people in it, and that includes everyone. That's the receptionist, the truck driver, everything. So the teams were quite small. They were nowhere near as professional as they are now. There's a lot more sort of camaraderie. People were pretty friendly, and of course we weren't a threat. In fact, we were a joke. So it wasn't as if people were against us. There was a bit of friction because this was the time when there was what was known as the FISA-FOCA war. So FISA was the predecessor of the FIA. They were supporting the sort of manufacturers, so Ferrari, Renault, people like that were in the FISA camp. FOCA was the Formula One Constructors Association, which Bernie was just sort of taking over, and these were all the people who were running essentially the sort of the cars with a DFV in the back. So you could go and buy a DFV, you could go and buy a Hewland gearbox, and you could build your monocoque and go racing, which is what a lot of British teams were doing. So there was a bit of a split between that, and we were on the FISA side. We'd gone with the turbo engine and everything, which was one of the differentiators. So there was a little bit of friction in that respect, but still, it was okay. But the professionalism I'd see in a Formula Ford team today was above what we had in Formula One in those days. You worked under an awning that was the side of the truck. You didn't have motorhomes or anything like that. You didn't have these fancy pit wall stands. You had to, you just stood by the pit wall with a stopwatch and things. So it was a totally different world.
Mm. So then, how did that then progress on? So was that now in Witney? Where was the actual?
It was in Witney. That's right, Witney in Oxfordshire. We had 3,000 square feet when we started, and then we took over about another 2,000. So tiny little units, and that was everything. That was manufacturing, that was the race team, that was R&D, it was inspection, it was buying, it was all cramped in there. Over the years we took on different units in Witney and sort of expanded around there until we built the new factory at Enstone. But by that time, Tolman had become Benetton. There was a bit more money in things.
I had a broader question to us at that point, though. If you look now, even though Formula One is arguably one of the biggest sports in the world, tons of money, there is an unusual location of teams in 50-mile radius of where we are now. Do you know how that started? Why that?
People call it Motorsport Valley.
Yeah.
And people have studied it, people have written about it. The Motorsport Industry Association, the MIA, actually coined the phrase Motorsport Valley. And I think it really started from March. Now, March were, I guess, going back to the 70s, even 60s maybe, they were the largest racing car manufacturer in the world. So if you wanted a Formula 3 car, a Formula 2 car, sports car, you went to March, they made these cars. And I think that then that really spawned a lot of subcontractors around, people who knew the sort of standards that were needed. People left March and they started up on their own. So it sort of grew organically, if you like. So then if you wanted to build a racing car, well, actually you might as well be in sort of Oxfordshire and Northamptonshire and that sort of area, because that's where the skilled workers were and it was easier to get them. And these things then, they grow, I said organically, it's actually virally they grow, because one generates another. And it's still true today, I think, that if you want to build racing cars and you want the right people, you want to be in that area. Something many years later, when I was doing consultancy work for Marussia. Marussia entered Formula One. They were based up in Yorkshire. And so when they took me on as a consultant, the first thing I did was move them down to Oxfordshire, because then you could get the employees that you wanted.
Yeah, wasn't there an example, maybe I'm misremembering this, but I thought there was an issue with Caterham. Something about they were in Norfolk, but they were struggling to recruit people and they moved. Am I right on that one?
Yeah, that's right. They were originally did start up in Norfolk. Of course, Lotus had been up in Norfolk in the old days, but that was really pre-Motorsport Valley. And Caterham moved down to Leafield, just a few miles from Whitney actually, and Oxford. Suddenly it became a lot easier. And even Ferrari have had a UK base for many years, and the sort of people know about the Guildford Technical Centre when John Barnard was there, and a lot of the work was done down there. But in fact, they've had a research group based in Oxford for many years.
I just find it interesting just how this centre of thing, and any team that's tried to almost go away doesn't really seem to work. Even like Haas, it's Banbury way, isn't it?
Haas are in Banbury, it's true, and it goes beyond that. Even the FIA, based in Geneva, they find it difficult to recruit the experienced F1 people, and of course now a number of them are actually UK based. So the aerodynamic group that you and I worked with, when they moved from Formula One management to the FIA, they didn't go to Geneva, they stayed in the UK.
Do you think, on a kind of related note a little bit, the expansion of Formula One into the US, arguably things like Drive to Survive and others. I work for an American company, and I remember in 2020, not many people really knew about Formula One. I would speak to my colleagues on the West Coast. It was kind of like, we kind of know about it, but it wasn't. Fast forward to now, and they're obsessed with it. They're really into it. The logical thing of that, I guess, is around teams. Do you think there'll ever be an opportunity where Formula One teams can be more based out of the US, or do you think there's just a fundamental challenge, beyond Haas, of really being successful?
I don't think we can be complacent in the UK. That large racing car manufacturing base that we had has more or less gone. Largest manufacturer of racing cars now is Dallara in Italy. A lot of the sort of Formula regional cars are made in France. So we shouldn't ever be complacent about it. But I would say at the moment, it's still quite difficult for the teams that aren't UK based. Sauber in Switzerland, Toro Rosso, who are in Italy, and Italy has its own little sort of Motorsport Valley, but even they are moving their design group over to the UK. In fact, have moved a lot of their aero people to the UK, just because that's where the talent pool is. So can it go global? It's a global sport, but I see no reason why it couldn't be have teams in the USA, because USA has a good racing heritage, and again they have this sort of subcontract base, supplier base. The supply chain is good there, so absolutely no reason why it couldn't happen. These days, out of the 24 races, only a third of them really are in Europe, so there's no logistic reason for it, and race cars don't really come back to base between races anymore, because the schedule is so hectic. So I don't think the geographical location matters much in terms of logistics. A little bit in terms of supply chain, but there's a good supply chain in Italy, there's a good supply chain in the USA. So it then comes down to the talent pool.
Yeah, I don't know if you've noticed that quite a few of my friends or friends of friends have almost left Formula One, some of them, and moved to work at places like Tesla. Or they've gone out to California, and there's actually a lot. If you look in these Teslas and Rivians, there's an amazing Formula One sort of group of people who moved over there, and that's why part of me was wondering, would a F1 team ever actually base out of there?
Yeah, I think that's a slightly different thing, because, for example, Peter Jones, who used to work with us, went to work for Ford in California as an aerodynamicist, and I think part of the reason we're seeing a bit of a migration now is the cost cap, which was introduced into Formula One. So there was a time pre-cost cap when Formula One wasn't sustainable. Teams were going broke, teams were living on the breadline, really struggling to be competitive, etc. Part of the reason for that was that actually you could earn a damn good salary in Formula One. And engineers were getting paid much more than they get paid working for these sort of exotic car companies, or even people like Dyson. Dyson were taking a lot of aerodynamicists recently. The cost cap came along, and there was a bit of a shift in the profile of the teams. The sort of more expensive guys were harder to justify to have so many of them. A lot of graduates are coming in on much lower salaries. You could have a lot of graduates working for the price of one of these more senior engineers. So I think a lot of the senior engineers said, okay, we've had our time in Formula One, we'll move on to other things. So I would say it's more to do with the cost cap than anything else.
Yeah, which I guess in some ways it's good for those graduate students that they're getting a chance to go to sort of get more easily in, or there's more desire to have them. Maybe less so for the people.
Yeah, I think that's true. There was always a place for the graduates because the teams were expanding so much. Going back to my sort of experience when we were at Benetton, we were working out of these sort of ever expanding industrial units in Whitney. Then we built the new factory at Enstone, the factory that Alpine are in now. And I remember when we built that, going into the design office and thinking, how on earth are we going to fill this? It was just enormous. And I guess at that time we were about 250 people at Benetton. And I've been over there recently, quite often actually. And firstly, you'd hardly recognise that old design office because it's been pushed in every direction. There are so many new buildings there. And of course the teams are employing around 1,000 people. So in that expansion, there was always plenty of room for the graduates. Of course, it did sort of asymptote at a point where, they didn't need to grow anymore, couldn't afford to grow anymore, didn't want to grow anymore, because it gets very, very difficult to manage these big teams. But I guess now, the graduates can get in for a different reason. Probably it's a little bit more difficult for them to rise up through the food chain. And it'll be interesting to see in 10 years' time just what the scene looks like.
Yeah, I guess, myself and probably others of our generation in some ways are slightly jealous of your generation, that you probably had it harder in a way because there was less people. But it seemed, because there was less people, it was, if you had the talent, you can take on more responsibility, and there was more ability to become a leader of a team. Where I guess now, as you say, if you've got that many people, statistically the chance of a graduate making it all the way up to a technical director.
Yeah, I think that's probably true up to a point, but I think the biggest difference is that when I started, you had to be a multidisciplinary engineer. I studied mechanical engineering, automotive engineering. I specialised in vehicle dynamics. I did the other courses. I did structures, I did engines and transmissions and things like that, but not a great deal. But when I went into the workplace, I really did have to teach myself. From that day walking into that porter cabin in 1976 and realising there was a drawing board there and no one else, and I had to just get on with it. Right through to my time in Formula One. So with Tolman, okay, we need to go wind tunnel testing. How do we do it? I don't know. Let's go and find out. So you go and find out. And I remember in those days, actually, I'd said earlier, we didn't really have access to computing facilities. And I remember in the early 80s, while we were in America, I bought my first computer, which was a Hewlett-Packard, an HP85, first sort of little desktop, one of the very first desktops. This is pre-PC. People might think there wasn't a world before IBM came along with personal computers, but it was. And it was a device that had its own little screen on it, little thermal printer on it. It had 32K of memory, which I expanded to 64. I got this thing back to the UK and I thought, well, what am I going to do with it? So I'd written a suspension program while I was at Hawke, so I put that on it. Programming in BASIC, because that was the only language on it, and decided to mechanise the wind tunnel. Now, if I'd known what I was doing, I would never have done it. But it seemed like the right thing to do because we had a manual balance on the wind tunnel. But it had some load cells and put some load cells on it. And then I got an IEEE interface that I could plug into the HP85 and I could start reading these load cells and things like that. And this was in the days when, you were programming, you come across a problem, you could phone up Hewlett-Packard and say, hey, I've got this problem. And they say, oh, well, try this, try that. It was a different world. But the fact was that, I was able to learn that. Later on, when aerodynamics was really becoming the thing, I had to sort of teach myself aerodynamics. I was one of the early adopters of electronics on the cars, building data acquisition systems. I wasn't an electronics engineer, I was a mechanical engineer, but I appreciated how I could exploit electronics. So I needed to learn a bit about them and I needed to employ some people. And so I really, right through my career, I've had to learn new things. I do talk about, my hobby being knowledge acquisition because I just love learning new things. And I think that's what keeps you going. Unfortunately, in Formula One these days, we have some really, really highly qualified, really clever people, but sometimes very specialized. So when you talk about this sort of progression and how do you get to be a technical director, a chief technical officer, something like that, there are some people, I could name them straight away, who I think absolutely have the intellect to do it. They have the engineering ability to do it. What they don't have is the bandwidth. And there are plenty of people who know their subject to the nth degree, but they don't necessarily know how to make a car go fast. And I know, Neil, you're an aerodynamicist, so I'll try not to be too rude about aerodynamicists, but, there is a thing with aerodynamicists where all that matters to them is the best number they can get in the wind tunnel. Yeah. And one of the things that I lecture to students is I try and lecture in the application of what they're learning into the real world. So a single number, getting a CL of 5.5 on your car, that's not what matters. What matters is getting a map that you can use so that the car can be set up so the car has good characteristics wherever it is. Again, and I'm not getting at aerodynamicists, but I've had people, in fact, even quite recently, have come along and they said, look, we've got this swing profile, it's absolutely fantastic. It will produce X newtons of load. And you look at it and you say, okay, so what structure are you going to put in there to support this X newtons of load? And they go, oh yeah, okay, it's a bit thin, isn't it? Yeah, it is a bit thin. So, you need, if you want to get to a technical director level, if you want to get to a CTO level, you need to know how to make the compromises, and you do that by understanding the total car. You need to know what gives you performance. And, for any engineering problem, which in our case is a set of Formula One regulations, there is a singular answer. we never ever get to that singular answer. But the guy who's most successful is the one who knows how to compromise. He knows which compromises to make. He knows, and that compromise might be a financial one. It might be a pure engineering one. It might be a resource one, human resource. Just knowing how to bring everything together, but fully understanding what gives you performance on the car, on the track, under every condition.
Mm-hmm. Well, that's one. I really would love your insight in this. So maybe using examples from the Benetton days. I always say to people, it seems odd in a way that you can have a team doing amazing for several years and then do terrible. And I often wonder, is this something just to do with not fully understanding just the immense complexity of turbulent flow over a car and all? It's just not a solvable problem. Is it a people problem? Like, why is Formula One not just sorted? We know how to design the car. Where some teams come out with something, it's awful. Now, how could that happen? Do you know what I'm getting at?
Yeah, I know exactly what you're getting at, and I've been through it. And it both ways. I think when I went to Williams, Williams had been 9th in the championship out of 10 teams for a few years. And I remember Frank saying to me when I went there, he said, I want you to turn the 9 upside down. You've got to aim at 6th. And, I did the normal sort of 100-day thing, 100 days of looking at it all. And I thought, I think we can do a bit better than that. And I realised that, I had a lot of very clever people there, some very good people, but they weren't working as a team. They didn't know what the objective was. And there was this terrible culture there. I guess 2 aspects to the culture. There was that this is the way we've always done it, which, you can't have in any business, I don't think, and particularly something as fast moving as Formula One. And there was also a terrible blame culture there. So there were these little silos who, there hadn't been good performance there for a long while, and each little silo was blaming the other silo. And it actually didn't take much to sort that out. And, my first full year there, we didn't go from 9th to 6th, we went from 9th to 3rd. We beat Ferrari that year. And in the years I was there, we finished 3rd twice and 4th once. I can't remember, maybe 5th once. But, we were successful. And then after I left, the team did go down again, because I think those sort of lessons that I tried to instill in people just disappeared. There can be other reasons. It can be lack of money. And if I take the Benetton years, the last years of Benetton before we were bought by Renault, we were really existing on a shoestring and trying to really compete in a way. We won a couple of world championships in the mid-90s. By the end of the 90s, we were really struggling to pay our bills. This was in the days when engine bills were just horrific. They were higher then than they are now, 25 years later. So those sort of things can affect it. But I think fundamentally, there are a number of factors that you need to get right to win championships. You got to have the engine right, you got to have the tyres right, you got to have the chassis right. In that is the aerodynamics, which is probably the most important bit. You got to have the driver right, and you got to have the team right, because the team is often underestimated. And of those 6 factors, if you got 4 of them good and 2 of them mediocre, yeah, you probably win some races. But if you're going to win a championship, you've got to have all 6 of them together. And, you've really got to set out what are your objectives, where are you going to invest, in terms of performance on the car. For every dollar that you spend on aerodynamics, you get a much, much bigger return than almost anything else. But that doesn't mean you can ignore everything else, because if you have fantastic aerodynamics on a terrible chassis with a team that can't do a pit stop and don't know anything about strategy and etc., you're not going to get anywhere.
So one of the things I was interested was, so as being a technical director, what would a day or a week look like? You know, how much could you delegate? How much was it about? How did you manage that? Because you were an engineer. Did you do project management qualification? Did you try and learn about? Because I'm always amazed at how do you manage a team of, I guess, egos and lots of people. Do you know what I mean? Did you just?
It's not easy. And I first became technical director at Benetton, and I'd been chief engineer for several years, and Ross Brawn was technical director. And Ross decided he was going to go to Ferrari. Michael Schumacher had moved to Ferrari. Ross was going to Ferrari. And Ross suggested to Flavio Briatore, who ran the team, that I should be technical director. And my first reaction was, I don't want to be technical director. You know, I've got the best job in the world. I'm chief engineer. You know, I can play with engineering. I have a passion for engineering that's equal to my passion for motorsport, maybe even greater. You know, I absolutely love engineering. And I thought, why do I want to get into being technical director? But they did a lot of persuading, and eventually I did it. And I don't regret it for a minute, because it opened up a whole new avenue in my life. Lots of interesting things. But the first thing I found, and it didn't get any better, it got perhaps more and more relevant, was that you can't do all your engineering that you like doing. You have to manage people. In fact, actually, years later when I was at Williams, I always used to say that at sort of 6 o'clock, I used to close the door of my office and I used to turn into an engineer. Because then people knew if my door was closed, don't come and disturb me unless it was really urgent. And then I could go through all the reports and I could, you know, start to sort of analyse things that we've been doing. But it's not easy. The teams are very large. You are managing huge budgets, and you're managing huge human resources. The budgets I never found difficult to manage. Don't particularly enjoy doing that bit of it, but it was never difficult. To me, it was just like being at home with a lot more zeros on the end. But, you know, allocating the financial resources where they needed to be wasn't too difficult. People are difficult, because I always think I like awkward people. I like people who are individuals. I like people who challenge. I like people who are really, you know, can be a bit of a pain in the arse to manage, because they are the ones who produce results. My ideal sort of employee is someone who does challenge, does question, does think laterally, but then once a decision is made, absolutely just joins the flow and says, right, we're going in this direction. But getting there can be difficult, and each person is difficult, is different rather, not difficult. And you have to learn how to manage each one of those individuals. It's not easy. I wouldn't say it's my forte, but it's something I think I've managed to do quite well. I think I can spot good talent. An awful lot of people in the pit lane now, in senior positions, not just in the pit lane, in factories, they're people who've worked for me in the past. So I do think that I spot good talent, and I do think I nurture good talent. I think sometimes I'm a little bit soft. You know, at Williams, I sort of invented this phrase that it's not who you hire, it's who you fire. Because sometimes you actually, if you want to change the culture, you need to get rid of some of the bad apples. But yeah, the management side of it is far more challenging to me than the engineering side of it.
And do you think that is in some ways what explains some of the differences between the teams? Do you think it is almost the leadership, the way that they prioritize decisions, hiring, firing? Do you think that actually could steer?
I think that's a large part of it, but I think the other thing is continuity. One of the nice things we had at Benetton was good continuity. You know, team that had been together for a long while. We reproduced it actually at Renault in the mid-2000s, where we had a team that had been together a long while. You get to that point where you know who you can trust, what you can leave alone because someone else will be dealing with it. You almost know how the other guy's thinking, which helps a lot in a rapid fire sort of situation, middle of a race, you know, things like that. And I think, you know, sometimes if a team has good continuity, we've seen it in Red Bull over the last few years. Maybe we might see that change a little bit. We saw it in Mercedes. People do underestimate that aspect of it. But yeah, I think, you know, you can't be on top forever. It's a natural cycle in sports, whether it's motorsport, whether it's Formula One, whether it's football. You know, you do see these cycles of things.
It is interesting though, isn't it? You always think, could they have done something different to have stayed 1 year better? Was it because that person left, which made that person leave, which meant that, you know what I mean? It was the one critical moment where all the cards collapsed.
The chain reaction, and what started the chain reaction. Yeah, it is interesting. I think, you know, it. I guess at Benetton, I think when Michael left, yeah, that did start a chain reaction because a number of people did go to Ferrari with him. Maybe you could say the same at Renault when Alonso left. So is it the driver that's the key? I mean, I'd find that quite difficult to argue, but you do wonder.
When I was at Lotus, there was a time when Kimi Räikkönen, I think, was there, and it was James Allison was the technical director, and it was looking like on the up. You know, maybe there would be a chance. And you know, I was quite junior, so I didn't know everything what was going on. But then we didn't get paid. I think one of the drivers left. I can't remember. I mean, James Allison left, and then I think Jared left. Mike, this guy was at Mercedes, Elliott, and there was this ripple effect of people going. Maybe because other people knew other people as well, wanted them to go with them. I know technically some of that you can't do, but you know, it happens anyway. And there was just that ripple, and then the funding got worse, the performance got worse, and you just, I always find that interesting.
Yeah, I mean, it's a relatively incestuous industry. People do know each other. You do tend to get together. I mean, you know, even when I moved out of the teams and I left Williams and went to work for Formula One management, and I was asked to set up a technical team. Most of those people were people I'd worked with, people I knew, people who I trusted, people who I thought, you know, had the right attributes to move from a big team to a small team.
What was that like then? So going, maybe fast forwarding, so you were in the sport for a long time, you took a bit of a break, you did some consulting work. How did the call come to join Formula One? On the other side of the fence, I guess, you know.
Well, prior to working at Formula One, I was working at Williams, and we had quite a falling out there. We've been very successful. You know, the most successful time Williams have had for 20 years and have had since then. But I was quite ambitious and also realistic. So, as I said, we'd had very good championship results in the 3 years I was there. I had a plan. I always have a plan. I normally work with a 3-year plan. I try and roll that every 6 months. I look at it. And so, a plan for where the company is going. And so I'd sort of presented that plan when I first went to Williams. I had support for it. In 2014, we finished third in the championship. Everyone was elated. And I said, okay, now we've got to move to the second step. And they said, no, we can't afford to do it. We need to consolidate. And I said, okay, right, I understand that. We can live with that. We'll delay by a year. But at the end of 2015, it was the same again. And we finished, I think we finished third again. And so, you know, there was this sort of, well, why do we need to do anything? And I said, we need to do things because, to be honest, Williams was 20 years behind the times in so many areas. And it culminated in 2016 where I just couldn't go on any further. And Ross at that time, who I maintained contact with, you know, Ross is a good friend, he was talking about going to Formula One because Liberty were taking over from CVC and Bernie Eccleston. Ross wanted a technical department in Formula One. There never had been one. He wanted to change from the sort of knee-jerk reaction of how regulations were made to put some science into it. So it was perfect timing, really. I was arguing with Williams. He was saying, look, here's something that's really interesting, totally different, really small team, but back to doing engineering and not managing, and thoroughly enjoyed it.
Was that refreshing almost? Was it a sense of going back to the old days of having just a small group of people? Was it?
Yeah, very, very, very much so. And you know, Neil, because you were part of that group at that time, you know, we used to do our weekly aero reviews, and they were really challenging, weren't they? They were really interactive. You know, we would really go through things in detail and look at it. And, you know, that little group of people, yourself included, produced the set of regulations that culminated in the 2022 car, where we'd set out to make a car that could follow another car much more closely. And we were remarkably successful at it, I think. The results were much better than I ever dreamt they would be when we started the project. But we did it because we were a small focus group. We were evidence-based decision-making, which is, you know, one of my mantras on everything. We weren't driven by anything else. We had no agenda. We had no one on our back. We just got on with it and did it.
Almost felt like a startup in that it was very quick for decisions to be made. You know, like the advantage of having a small group of people almost felt like a skunk works or something where you can very quickly iterate. Like now, I don't know if you have it in when you deal in sort of bigger organizations, just to try and get a meeting organized can take forever because you've got so many people, you know, these people are away. When you've only got 4 or 5 people, it's very easy to just to have a call, isn't it?
It's absolutely true, and it's so applicable in other areas. You know, Formula One is my main work at the moment, but I do other things, and been doing some consultancy for a very, very large PLC who wanted to know how to innovate. And as a result of discussions with them, that's exactly what they're doing. So they're trying to make the little skunk works that really handles their R&D.
Yeah.
There's a lot to be said for that.
Yeah, definitely. Looking maybe a bit more to the future. So one of the things I guess we started talking about, I'm sure you've thought about it before as well, but in those rules change was the role of, as you said, keeping the sport to be in the future, not 20 years behind. There's a mentality of just doing it the same as you've always done it because that has led to success. And one of them is obviously the wind tunnels, the simulation, the high performance computing. Where do you see the sport going? There was obviously some announcements made in the past about wind tunnels and the ambition to reduce them. You know, where do you see the sport going, or where would you like to see the sport going?
I think that the first thing we've got to remember is it's a sport and therefore it's an entertainment. And we engineers love playing with it because, it's engineering at the forefront. And we need to keep an aspect of that because, that is part of the mystique of Formula One. One of the things I found when I went to work for Formula One management was that a remarkable number of people are interested in the technical side, much more than I thought, which is quite gratifying as an engineer. But I think that what we need to do is we need to stay on the forefront. And if you take aerodynamics, for example, CFD, we absolutely were at the forefront. When we started CFD programs, I guess in the 90s, we were really pushing the vendors, the software vendors, and saying, look, we need this, we need the turbulence models improved, we need this, we need the other. And we were really, really pushing. And I believe that we made a fundamental difference. And I always quote as one of the areas where motorsport contributes, because a lot of people think, well, motorsport might give us better engines or better brakes or something on our cars. But of course, we have a much wider influence than that. And I think that the work we did in CFD in those early days on turbulence models, I know had a fundamental effect on building wind farms. Because, of course, if you want to model a wind turbine, it's not a terribly difficult thing to do. But if you want to model a farm of wind turbines, each one working in the turbulent wake of another one, you really needed to get into these turbulence models that have been really pushed by the Formula One guys, because unfortunately we have a very, very unaerodynamic device that we try and race, and with a lot of turbulence. And therefore, those sort of things, they led to the wake steering that you see on wind farms these days and things like that. So we need to keep at the forefront. And unfortunately, because we're always trying to just contain costs to a sensible level, CFD, computational fluid dynamics, is one of the areas where perhaps we've allowed things to fall behind. And it was one of the great things of going to do the project at FOM, because we didn't have the constraints of regulation. So we could move to these much more sophisticated models. And if you remember, our sort of gold standard was a fully turbulent model of two cars in curved flow. And, that is computationally pretty damn intensive, and not the sort of thing that teams want to do because of the resource it takes up. So we've got to make sure that we do align things with that. There's a move to, I'd say, get rid of wind tunnels. That's perhaps going a little bit far, but certainly to reduce their use. And over the years, we have been reducing their use because they are expensive machines to run. They use a lot of electricity. But we mustn't lose sight of the fact that CFD actually uses quite a lot of electricity as well. And, as we're trying to decarbonize the sport, we need to be very aware of this. Now, I think one of the areas everyone's talking about, one of the areas we've got to promote is AI and ML. And it's not new. Believe it or not, in the late 1990s, when I was technical director at Benetton, I started a program to look at how we could use neural networks to improve the vehicle handling. And in those days, we built our own data acquisition systems. And I designed our total data acquisition system to be, if you like, database-based, so that you could interrogate it. And we started working with Sheffield University on a neural network system that would be able to interrogate how the car was set up, what the data from the car was saying, relating that to the drivers. So we actually had to then get the drivers to be objective rather than subjective, which is perhaps the most difficult bit. And we were years ahead of our time. In fact, we were so far ahead of our time that actually the project in the end failed because we didn't have the computing power that we needed. And also, of course, in those days, you couldn't go and buy ML APIs to plug into your stuff. You had to write it all yourself.
It is amazing, actually. I don't know exact details on this, but that time you mentioned could well be the time that has now become quite famous as, why is AI/ML suddenly popular now when these methods, and there was this sort of winter, they call it, where, so you were probably at that time where, yes, the theories had been done, but because the GPUs and the computing power wasn't there, it sort of didn't look attractive almost.
Yeah, absolutely. I mean, in fact, it wasn't even running on GPUs then. You know, a GPU, I guess there were GPU chips, but, you know, they were very, very primitive. And certainly they were what they said on the tin. You know, they were graphics processing unit. That's what they were made for. So the idea that a GPU could do something different really wasn't around. We were trying to run these on standard Intel 80 series type processors, and yeah, it was difficult. It was more than difficult. So, you know, we were trying to take something from technology, TRL, technology readiness level 3 up to 8 or something in that really difficult area. And we simply didn't have it. Whereas now, yeah, you know, it's accepted practice. The computing power is there, the knowledge is there. You can go to someone like AWS and you can buy the modules, you know, that will help you get there. But we started this conversation by saying, will these sort of techniques take over from wind tunnels? And again, in the project to produce the 2022 car, we started looking at quite a lot of ML. And in fact, now we know that it is, if we can look at the wake 1 meter behind the car, using ML techniques, we can predict the wake 40 meters behind the car. And that's a really valuable thing. But a lot of these techniques are quite intensive. And you and I have spoken about this. You know, we've spoken about the fact that I think that a lot of people think that the intense time with any ML type system is the training. And yes, it is intense, but the utilization is also intense. And you know, some of the figures that we've seen of just doing a simple Google search or an AI-driven Google search, where from memory it's sort of less than 1 watt hour. It's about 0.2 watt hours to do a standard Google search, and it's anywhere between 7 and 9 watt hours to do an AI-driven Google search. You know, these things become significant. We have these huge data centers now which are consuming enormous amounts of power. We really need to think about it very holistically. AI is fantastic. It allows us to do many things. Yes, there are concerns there. We need to be careful, and we need to recognize those sort of things, because it is very much black box, and that worries me a lot. But equally, it is the way of the future. Yeah.
And do you see any, if you were to watch Formula One in 2040, do you have a sense of what you would see? Have you looked out that far to imagine the...
My job's to look out that far, and I find it very, very difficult, because at the moment Formula One is very much tied up with the motor manufacturers. And in fact, when we were doing the 2026 regulations, my initial thought was that we wouldn't have the car manufacturers with us. You know, everyone was talking about electrification, battery electric vehicles. That's where they're going. So I thought it's going to be hard. But in actual fact, not only have the people who were involved stayed, but we've got new people coming in. We've got Audi coming in. We've got Ford coming in. We have Porsche wanting to come in. They didn't actually make it. We've now got General Motors wanting to come in. So it makes me think, well, okay, so that's 2026, 28. What on earth are we going to do 2040? You know, are we going to get to a point where actually our program on sustainable fuels which is a program I'm very proud of that we're doing in Formula One that I initiated, is that going to be something that saves the internal combustion engine? Or are we in fact going to get battery technologies that really make, and battery infrastructure, charging infrastructure that makes battery electric vehicles almost universal, in which case will the motor manufacturers want to still be with us? Because that makes a very, very fundamental difference to how we go about our racing. It doesn't kill racing any more than, they ran the Grand National at the weekend, but no one went there on a horse, did they? They drove there. So racing will always be there. And maybe if we look at 2040, if everything is battery electric vehicles, even on the heavy stuff maybe by then, which will require some big breakthroughs, maybe providing we're running sustainably and we're running with a sustainable fuel, whether that be a liquid hydrocarbon fuel or a synthesized liquid hydrocarbon fuel, or whether it's hydrogen or whatever it might be, maybe we just divorce ourselves from everyday transport in the same way that horse racing has from.
It does seem that way, that potentially there is almost like a nostalgia at that point of maybe there's a desire to see racing or things that are not. Do you know what I mean?
I think fans would be very, very pleased if we went back to high revving V10s, V12s. We constantly get that feedback because obviously in my role now we do a lot of fan surveys, so we constantly get that. Motor manufacturers want us to be pushing battery chemistry, inverter technology, to some extent motor technology, hybridization, highly efficient internal combustion engines, that sort of thing. But actually, if they were not part of the scene, then I guess we would go about things differently. So really, really difficult looking out that far.
So final question for you. You said that it's actually more engineering than motorsport in some ways that drives you. Do you have any sort of bucket list things or desires that you've done pretty much everything I can imagine, but is there anything else you're like, that's one thing I'd love to work on or do?
Yeah, I think there is. In fact, I suspect there's more than one. But as I said, I started really as a mechanical engineer. I was taught some automotive, I had to learn an awful lot more automotive, tyres, a subject I find fascinating, and I was taught very basic tyre models, whereas now I've really got into thermal tyre models and things like that. Aerodynamics, very much self-taught. Electronics, very much self-taught. But I do find this whole area of AI and ML really interesting, and it's certainly an area I want to keep on top of. As I say, I was an early adopter, too early. And I see incredible possibilities and I see incredible pitfalls. And I guess one of the things that worries me, I'll give you a simple example. Let's imagine, I've got a huge expanse of land and I've got a lovely little stream running through it, and I think, I need a bridge across that stream. And to be honest, if I want to walk across that bridge, I know I can put down a couple of bits of 4x2 timber and a couple of planks on top of it, it'll be fine. And then I think, actually, maybe I want to drive my tractor across it. I'd better calculate it, but that's fine. Yeah, it's an easy calculation to do, to look at what I need on that bridge. And then I think, actually, there are a few different ways I could do this. So maybe rather than just doing a hand calculation, I'll write a computer program. And I write a computer program and it looks at the various options of the sections of wood or steel that I could use, and et cetera, et cetera. And I build my bridge and I drive my tractor over it and it falls in the stream. So I think that's odd. I go back and I look at my computer program and say, oh, yeah, sorry, I made a mistake there. That's fine. I'm in control of it. If I use an AI system to do that, and the bridge falls down, it's a black box. Where did it get the information that was wrong? They call it hallucinating when it starts to make it up its own things. And yeah, that's a real concern, because there is so much of a culture now of believing what's on the internet, believing what comes out of a computer. With AI being trained, or ML being trained, so much of just on what's on the internet, it's not all true. And some of the inferences that can be drawn from what's out there are really worrying. And there's no way of checking it. I can't go back and look at my code and say, oh yeah, hang on, I missed out a decimal point in that line of code. So I have that caution. I don't have the worries about it taking over the world that some might have. I have the worries, of it being misused by bad actors, because unfortunately, that's what happens so often. We've seen it with the internet, and we should learn from the internet, because the internet was badly regulated, and we should learn from that. And we should make sure that any form of AI, particularly when we get to AGI, the artificial general intelligence, we've got to make sure we're regulating it. So, yeah, that's the bit I would like to get involved with.
Not just a small,
just a last little project.
Only take a year or two. Great, Pat. Well, thanks so much for joining. Really enjoyed this talk, and yeah, thanks again.
It's a pleasure.